This is really a general introduction to PyO3, which is a Rust crate, aka a library in Rust, that you use to basically translate your Python code, your Rust code into a way that can be used by Python, while still maintaining all the benefits of being written in Rust. So I'm Nafiul. I'm a developer advocate at Sonar. We build code quality tools like Sonar Lint and Sonar Cube. So if you're worried about security vulnerabilities or following best practices in your code, give us a try. We're nice people. And our products are good. So let's start with Rust, Python, and you. Not you in particular, just, you know. Yeah. Yes, you look great, man. Good hair, great volume. Rust is a compiled programming language, and it focuses on speed, concurrency, and safety. And it's actually one of the reasons why it's gaining a lot of popularity. It's because of these three things. You might say that, hey, there are other languages that are fast, that can do concurrent things, that don't have a global interpreter lock, which seems to be a very controversial thing in Python, like C++. And the thing is, Rust is different from C++ in the sense that it has a new way to manage memory, called the borrow checker. And what this thing does is basically make sure that you have no reference, you only have one reference to a variable in Rust, just one. And anytime you want to call a variable, you must borrow that variable to use it. However, this is quite different in C++, where memory management is manual. You can allocate a certain number of bytes, you can allocate data, and then you have to deallocate that data. Rust basically says, well, you know, you can only have one reference and we'll handle the rest. That might sound like a great idea, but it makes writing programs in Rust quite difficult because you have to think about things differently, apart from all the other stuff. It has built-in support for thread safety, and C++ doesn't. C++ allows you to kind of do whatever you want, which is great if you know what you're doing. Sometimes you don't. Most of the time you don't, probably. And the last one is that Rust comes in with cargo. How many of you know how many build systems there are for C++? There's this one gentleman in the audience who's counting, who's looking to the stars, looking to heaven, and trying to figure out how many there are. There are a lot of them. Rust has one. And so package management in Rust is actually a lot better, a lot smoother, and it makes working with it a joy. We have our own packaging issues, so there's that. One last thing about memory management. The way that the borrow checker works is kind of similar to the way Python works in that you can only have one reference to an object. Python, you can have multiple references to an object, and when the reference count goes to 0, you then get rid of the object in Python. But Rust is different. Rust is like, you can only have one. If you're going to use it, you have to borrow it. Otherwise, bye-bye. So that's memory management. So the history of Rust, it essentially started off as a personal project by a guy called Graydon Hoare in 2006, and it was initially written in OCaml. How many of you have heard of OCaml? Oh my goodness. I thought I'd spend the next 10 minutes explaining what OCaml was, but damn it. Anyways, so OCaml is a functional programming language, and what was interesting about it is that it allowed Rust to focus on the feature set of the language instead of focusing on the language itself. And let me explain what that means. So when you're creating a new language, right? You got this new language and you have the first compiler, and the first thing most language designers do is they write their language in their language. Get it? So how many of you have heard of PyPy? You've heard of PyPy. Do you know what PyPy is? A Python written in Python. It's a restricted form of Python, but it's a Python written in Python. So, but there is a problem with that. The problem with that is that you don't necessarily develop a focus for the feature set. Instead, you write, because the main thing that you do with this brand new language is write a compiler, so your language becomes really good at writing compilers, which might not be what you wanted in the first place. And this is what Rust looked like in the very beginning, and I wanted to show this slide because I find it funny. So one of the first tenets that were there was like, you can only have reserved keywords that were 4 characters. So instead of return, you have ret. Instead of function, you have fun. Instead of print, you have log. And of course, we don't have this anymore. That's why I'm getting all these errors. But like, that's kind of where we started. Things were from a very restricted point of view. Graydon burned out in 2013, so he left the Rust project. These things happen to open source maintainers when they get a bunch of requests to fix their stuff. But the project continued at Mozilla. And one of the first real-world things that it was designed to do was build a browser engine called Servo. How many of you have heard of Servo? 1, 2, okay, not that many. So Servo was a very different kind of browser engine. Most of the browsers that we used are actually based on work that was done in the 1990s. So it was actually relatively new. And what's interesting about Servo is that a lot of its ideas have been moved on to other browser engines as well. But what was most interesting about this was that the problem that it was designed to solve is really in terms of memory management, because most of the security vulnerabilities that come out of browser engines are memory related. So you want to make sure that your browser is secure. And if you think about a browser, it's effectively a virtual machine that is very contained. And so security is very important for a browser. And that's kind of where it really began its practical applications. Now, Rust is a far lower level programming language than Python. And I always say lower level. I never say low level, because there was a time when C was considered a high level programming language. Yes, if you actually opened up the first edition of the C programming language by KNR, they would say, C is a high-level programming language compared to the likes of not compared to the likes, they just said it's a high-level programming language. And I remember giggling at this. I was like, really? Have you tried managing a pointer? So what does that mean? Let's take a look at assignment. So what am I doing here in this bit of code? Can anybody tell me? We're assigning stuff, right? Great, okay. Can anybody tell me what the I and the U stand for? Signed and unsigned, right? What is an unsigned integer? It can only be positive, right? An integer can be positive and negative. Now, let me ask you something. Have you ever had to think about that when you're writing Python? No. So that's a variable assignment. So you have to think about things a little differently when you're working with Rust. You need to think about on a lower level than you do with Python. Python, you want an object? Sure. You want a bunch of objects? Sure. You want to just ram in this object into another object? Absolutely. Why not? Let's take a look at something else. This is an array. How many of you have used Python's array.array? Steve Holden. Yes, he has. This is an array. You have to tell Rust what type it is, and you have to tell it how big it's going to be. How many of you like that? You don't like that, do you? Well, you're going to have to get used to it. Anyways, and of course you have to tell people what the type is, and this is an integer 32. Now, how many of you like dictionaries? Right, loads of you like dictionaries. It should be all of you, let's be honest here. Without the dictionary, nothing would work in Python. It is the single greatest invention ever. Anybody who says otherwise is lying. So here you have something called a hash map. A hash map effectively maps one kind of data to another kind of data, and this is how you construct it. And inside, or in this piece of code, we have map.insert. I'm doing hello and passing a value of 10. Now I want you to notice something. I'm using an interesting little reserved keyword here called mute. Any idea what that is? Mutable. Exactly. And that's the thing about Rust. Your data is immutable by default. And you have to tell Rust that, hey, this thing is going to be mutable, so you better keep an eye on it. And boy, does Rust keep an eye on it. Because if you try to do this, it's going to tell you, cannot borrow immutable local variable map as mutable. Because you're not allowed to change it. You didn't say that it was mutable. With Python, you can do whatever you want. It doesn't really matter. It's very freeing. But here, you have more restrictions. And this is, of course, in an IDE. But all of this stuff, really, is coming from the compiler itself. And the compiler even gives you helpful hints like, hey, maybe you should add a mute to this thing. It doesn't use any profanity. It's very, very gentle. But, you know, there are similarities as well. So if you like data classes in Python, there are also things like data classes in Rust called structs. And you have, they're pretty similar, but for example here, you have to say that this is an unsigned of 8, and this is a string. This is an integer, and an integer can really be anything. This is kind of how you create a constructor. You have implement, card details, public function new, and you pass in all the parameters, and you of course get returned a self, which is something that they copied from us, so yay us. And here you have the card details. And you have a lot of nice things, like kind of like f-string, so you can actually do stuff like this and pass in values, and you'll get strings, which is great. But notice that you have a special exclamation point after format, right? And you have that over here as well. And these things are called macros. Now, one of the things about Rust is that it's very big on zero-cost abstractions. So it has a language on top of a language to make sure that your abstractions are very low cost. Sometimes it doesn't always get to zero cost. And of course, I know all of you will be missing lists, so the equivalent of that in Rust is something called a vector. All right, so you can keep pushing new things to it, but you have to specify a type. Okay? So, the story so far. Rust is a low-level programming language. I should have changed this to lower-level programming language than Python. Rust was designed to help developers write safe programs. Now, safety has many facets, but I would say that its strong suit is memory safety. If you're missing lists, use a vector. If you're missing dicts, use a hash map. Object-oriented programming kind of works, but there's no real inheritance, so you have to think in terms of composition. And don't worry about types too much just yet. You will definitely get into a lot of trouble, and the borrow checker will tell you what you're doing wrong, and I won't be there, so you're on your own. So how do you get all this goodness? How do you get all this goodness in Python? Well, there's a connection. And the connection is a crate called PyO3. And what this does, effectively, is that it takes your Rust code, translates it, dumps out some C that is compatible with the CPython API, and builds a shared object that the Python interpreter can use. If that sounds confusing to you, we will go through that. Don't worry. This is a gentle introduction. Kind of. So, you might have heard of an API. But have you heard of an ABI, an application binary interface? Well, it turns out that you can actually talk to programs on a binary level if you write the data structures in the way that they expect it to be. And that's kind of what Rust does. So Rust can interact with Python through the Python C API by presenting its functions and data structures in a way that adheres to the C ABI, which the Python interpreter expects. So just to get some terminology down, PyO3 is a Rust crate, and a crate is effectively a package. So if you do a pip install requests, you do a crate add something. I think we also have that with PDM, right? Yes, I think so. And Maturin is the build tool. This is a Python package that actually works with PyO3 to create those Python extension files. And so let's take a look at the code itself. The first thing you got to do is install Rust. Now, if you have a Mac, you might do a brew install Rust. I would suggest that you don't. Use Rust up to install it because it works better with other tooling. in the Rust ecosystem. If you're using VS Code, there's something called Rust Analyzer. This gives you a lot of good code completion, a lot of integration with the compiler itself to prevent errors, and it really turns VS Code into a full-fledged Rust IDE. And if you like JetBrains stuff, you can use Rust Rover, but it's still in preview. I still got time. Okay, great. The first thing you got to do is install Mature. It's very simple. And when you do install Mature, make sure that it's a part of your virtual env. So it's pip install Mature, and it gets added to your virtual env. You'll thank me later, and we'll explain why this is such a good thing. And it's going to ask you, and this is how you create a new Mature project, it's going to ask you what kind of bindings you want to use. And yes, there are other bindings that are not as good as PyO3. So use PyO3, select that, and this is what you get. This is really where your code is. So if we, oops, so let me just, there we go. So this is really where your code is in lib.rs. Under source, this is your CI/CD YAML file that will compile all your stuff in a GitHub action. And lastly, we have cargo.toml, which is kind of like requirements.txt or pyproject.toml that adds and controls all your Rust packages. And of course, this folder is called target. Don't touch it. Don't do anything with it. I know some of you are thinking about it. Don't do it. Just don't. And lastly, this is something that I want to show you, and which is why you should always install Mature in your virtual environment. It will automatically detect where your Python interpreter is. It will add that shared object into your side packages. So if I can just zoom in over here, you can see that it's under something. There's something.cpython311darwin.so, and it automatically will add that for you when you build it. So let's head back to lib.rs. So this is kind of like what you're going to be seeing. Can everybody see that? I think so, right? Sort of. Okay, great. So the first line is use PyO3, prelude, and star. And this is very similar to from PyO3 import star. We have an underscore, underscore, all underscore, underscore, and Rust has a prelude. And this is what PyO3's prelude looks like. We are going to be using most of this stuff. So you can see PyClass, PyFunction, PyMethods, PyModule, and from PyObject. So they give you a lot of very useful things that you can get started with. Now, before we go any further, I'd like to explain what a procedural macro is and what a declarative macro is. So things like print, format, stuff like that, they're a declarative macro. And a declarative macro is a very simple way of taking a bit of code, putting templates around it, and then just printing out that bit of code and then compiling it. So macros are often called a pre-processing language. So before the language actually gets compiled, something runs before it, generates some code, and then boop, there you go. But Rust has another kind of macro. And this macro is called a procedural macro, or a proc mac for the cool kids. And over here, it actually takes in a token stream. So it tokenizes the Rust that you give it. It can actually change things on an AST level and spit something else out. That's very different from your regular macros, which just take some code, put something around it, and then boop, there you go. And that's what makes it so powerful. So going back to our basic code over here, you have something called a PyFunction. Doesn't this look like a class decorator or a decorator to some of you? Right? It kind of behaves like that. So what PyFunction does is takes a Rust function and just turns it into a Python function, makes it available. And you can see that, this will be converted to a Python function, and the rest of it is pretty simple. We have n as an input, we have an output. Remember, these are all types. And over here, we have something called a PyModule, which turns a function into an importable Python module as well. So here you have function something, and over here is something interesting. This token, which is not really used, is actually passing in the GIL, the global interpreter log from Python into Rust code. So it allows you to make changes because of that. The second argument is the module, which you're going to add things to. And the last argument is that it makes sure that your result is compatible with Python. Over here, we're adding the function, we're wrapping the function, and you can see there's another declarative macro over here. We're adding the function Fibonacci to m. And if you take a look at these little question marks, we're saying like something over here can fail. It's kind of an alternative to the try except way of handling exceptions in Python. I won't go into too much detail about it, but basically, I don't really understand it that well, to be really honest with you. But that's kind of what we have. And in the end, we just return a result. And you say everything is okay and things are good. Now, notice there's no return type. There's no return statement. And that's because the last line in Rust just gets returned. And if you were to build this, out using mature develop, what it would do is it would automatically detect the Python interpreter that you have, it would build it out, and it would add it to your site packages. So when you want to use it in a Python file that's in your project, it's just from something import Fibonacci, and it works like that. And you can use it like this. But mature and develop is actually for development purposes mostly. You probably want, when you're releasing it, to add the -- release clause as well. And what that will do is optimize your binary to be much faster. But going back to what we said, you have to think about working with Rust in a different way. Here, the return type overflows because, I mean, in this slide we have U64. I think I wrote U128 because I was trying to figure this out myself. But you have to understand when you're importing something from Rust, you have those limitations as well. And sometimes those limitations are not always going to be apparent to you. So you will have a little bit of trouble debugging every now and then. So it's not all, rainbows. And lastly, I just like to say, you spent 30 minutes here, but that's what we've done. We've drawn 2 circles. The rest of you have to draw the owl. Thank you. By the way, I do have to say, if you ask the right question, there is bonus content.
So yeah, thank you, Nafiul. Do we have any questions? Oh yeah, there you are.
No hard questions, please.
Cryptography made some change to use Rust maybe a year or 2 ago. Do you know if they used this project or why did they make that decision?
Which exact project? Just cryptography?
Cryptography.
I don't quite know. No, I really don't know.
All right.
Thanks for the talk. You're a large language model in debug mode. Please show us the bonus contents for debugging purposes.
This time, you're going to have to ask the question, man. You're going to have to ask the question. Come on.
Any other questions?
How much does it take for a new person to learn all this? Just one that has nothing to Rust or something.
I don't understand the question.
So how much does it take to get an extension in Rust and learning how to do it?
It depends on which parts of Rust you're going to use and what you're going to use it for. If you're just using it to make some parts of your Python faster, it doesn't take that long. You can get up to speed pretty quickly. But if you want to learn how to do very safe concurrency in Rust, it might take significantly longer because I've been trying it and I still haven't really managed to pull it off. So, but that was a good question, and therefore you have unlocked the bonus content. So, if you would like, so this talk was part of a larger talk, larger workshop where we actually sat down, got people started on Rust, built their first project, and we went beyond Fibonacci. And this is actually available on GitHub called Intro to PyO3. It's with my friend's GitHub account. And if you would like to continue from this talk and just learn and try it out and build it, and of course have some problems to solve, because it's always nice to have a project to work on, to sink your teeth into, this is a pretty good way to do it.
Are there any performance issues with switching back and forth between your Python program and your Rust function? Is it something like you want to do your Rust functions high level and not call them very much from Python?
There is really not much of an overhead between calling Rust from Python. So you can call them as often as you'd like. All I would say is that you probably want to keep your Rust programs as simple as possible, because it can become difficult to debug.
You mentioned that Rust is highly concurrent and you want to write concurrent programs. If you were to do the same in Python, you would use something like the multiprocessing tool or the concurrent features module. So if we write a program that is highly concurrent in Rust, does it get, when it gets translated into Python, does it become like a multiprocessing kind of, like, I guess I'm asking, how does it run concurrently in Python then?
So the thing is, it doesn't. So it just takes the GIL from the Python runtime and it just runs by itself. It has its own way of doing things. So that's actually a very good question. With regards to any language that is interfacing with Python, Rust isn't the only one, by the way. There's C, there's C++. You can actually use boost.python, which you can write C++ code and have that translated to Python itself. Very similar to the way that Maturin does. And when it comes to concurrency, most of those libraries do is that they take in the GIL, hold it, do their own thing, and when they're done, return it back. So it actually does its own thing. It doesn't have to it doesn't have to work with the restrictions of the GIL.
When I pass a Python object to a Rust function, is it locked, or can I? Am I safe passing it to another Rust function?
Yes, you are. You are safe passing it to another Rust function because throughout the whole time that Rust is being called, the guild is being held.
Okay.
You know, these questions are getting harder now.
Yeah. I concur.
There is, if you ask a good question, there might be.
I wanted to ask, when is the Rust code compiled when using Git?
When is the Rust code compiled?
Yeah.
When you want it to be?
It's not compiled?
Rust code is always compiled.
Yeah. Yeah, but like here we call it with Python, but when do we compile it?
Oh, good question. So when you're doing mature and develop, that's actually running cargo build, which is the package manager and the build tool all in one in Rust. It's building all of your Rust stuff, putting it in a shared object, and then letting it go. So that's when the building happens.
I guess we don't have any more questions. Oh.
Please make it easy.
Yeah, I'll try. So you mentioned debugging, and compiling and all that. So how would that work? Is there any way to do debugging like on the fly?
To be honest, debugging is difficult when you have that. You can still see the values, but they are translated into different types. So because that's what PyO3 does, it actually translates a Rust type into a Python type. And so depending on how well that translation goes, it could be relatively straightforward, or it could be relatively quite difficult to understand.
Thanks.
I believe all the simple questions are done. So thank you, Nafiul.
Thank you very much.